We want to turn our attention now to linear inequalities that involve absolute value. And you can see over here on the board I've written this first one, absolute value of 3y plus 9 greater than or equal to 6. Now we're going to use the definition for absolute value to reason our way through the solution to this. And the first step really is the important step as far as understanding what this means. So when I look at this, the absolute value of 3y plus 9, I know that means the distance between 3y plus 9 and 0 on the number line. So the way I read this expression is the distance between 3y plus 9 and 0 on the number line must be greater than or equal to 6 units. So that means that I can draw a little number line in here. I'll put in 0, negative 6, positive 6, and I know that I can find the expression 3y plus 9 below negative 6 and above positive 6 because the distance between that expression and 0 has to be greater than or equal to 6 units. So with this diagram, I'm just going to say 3y plus 9 is less than or equal to negative 6. That will be what happens if 3y plus 9 is in this region. Or it could be that 3y plus 9 is over here, which means that 3y plus 9 is greater than or equal to positive 6. So this is how I reason out the solution to this inequality. 3y plus 9 could be down here, in which case its distance from 0 is more than 6 units. So that means 3y plus 9 is less than or equal to negative 6. Or 3y plus 9 could be up here, and its distance from 0 is still more than 6 units. So 3y plus 9 greater than or equal to 6. Now I'll simply solve these two inequalities to get my solution set to my original absolute value inequality. Adding negative 9 to both sides here, I have 3y less than or equal to negative 15. Multiply both sides by 1/3. Y is less than or equal to negative 5. Or I'll solve this inequality by adding negative 9 to both sides. 3y greater than or equal to negative 3. When I add negative 9 to both sides, I have negative 3. Multiply both sides by 1/3. Y is greater than or equal to negative 1. So here's my solutions. Any y that's less than or equal to negative 5, or any y that's greater than or equal to negative 1. So as far as the graph of the solution set, I'll put in negative 5. I'll put in negative 1. I want to graph all the numbers that are less than or equal to negative 5. So I'll use my bracket notation. That tells me that the end point, negative 5, is included in the solution. And I'll use my bracket notation up here to show that negative 1 is also included in the solution. So here's the graph of the solution set. If I want to use interval notation, I'll say that this region is all the numbers on the number line from negative infinity up to negative 5 and including negative 5, union with all the numbers in this region on the number line, which starts at negative 1, includes negative 1, and goes out to positive infinity. So interval notation for the graph of the solution set right here, or the graph. Either way we want to write the solution set, we have it. This is the solution in terms of just inequalities. So that's our first linear inequality that involves absolute value. Let's look at another problem. In this case we have we want to solve the absolute value of 3x plus 5 minus 8 less than 5. Okay, I want to do the same kind of reasoning I did on the last problem, but to do that I need to isolate my absolute value symbol over here by itself on the left side of this inequality. So I'm going to start this by adding 8 to both sides. So when I do that, I have the absolute value of 3x plus 5 is less than 8 plus 5 is going to be 13. So now the absolute value of 3x plus 5 is less than 13. Okay, I reason it out this way. The absolute value of 3x plus 5 is its distance from 0 on the number line. What this expression tells me is that that's less than 13 units. So I'm going to draw a number line here. I'm going to put in 0, negative 13, and positive 13, and ask myself where the expression 3x plus 5 is. Well, it's less than 13 units from 0, so it's got to be in here. It's got to be between negative 13 and positive 13. I can write that very easily using my continued inequality expression. So negative 13 less than 3x plus 5 less than positive 13. So I know my 3x plus 5 is in this region on the number line. That will translate into this continued inequality, negative 13 less than 3x plus 5 less than 13. Now I just have to solve it. So I'll start by adding negative 5 to each of the three expressions here. So I'll have negative 18 less than 3x less than 13 minus 5, which is going to be 8. Next, I divide the center expression by 3 to just have x, so I'll do the same thing to the outside expressions. Negative 6 less than x less than 8/3. So here's my inequality that's the solution to this absolute value inequality. Let's graph this solution set. I'll draw in the number line with a negative 6 here and an 8/3 out here. I'm going to use my open braces here, and then I want to color in the middle. So this region on the number line corresponds to this inequality. Now I'll write the same expression using interval notation. It's all the numbers on the number line from negative 6, but not including negative 6, up to 8/3, but not including 8/3. So with interval notation, the solution set looks like this. With the graph, it looks like this, and with inequality notation, it looks like this. So there's a quick look for us at how we solve linear inequalities that involve absolute value.